Okay, for section 5.2, the first thing we're going to talk about is just how the two different forms of an exponential function, this one right here and this one right here, are pretty much exactly the same thing. We talked about this a little bit in chapter 4, but it'll make a little bit more sense as we do some things in this section. So first things first, I want you to recognize, I have to zoom in a little bit here, that we have a b to the t, and in this form we have a e to the kt. If you look at the b and the e to the k in both of those scenarios, you will find they're in the exact same place and they represent the same thing. So the biggest concept you have to understand for section 5.2 is that b equals e to the k. If you can remember that, your life will be so much easier. So we're going to apply that right away in this first example. They want us to fill out this chart. So the whole purpose in this chart is for us to kind of think about these different formulas as far as what they say about the situation, and also how to convert between forms. So first things first, I'll go to this very first row. You'll notice in the first row they have this given to you. Okay, so this is the formula in what we would call the continuous format, where it's the e to the kt format. We want to convert this and make it a q equals ab to the t format. So we're going to set up our little equation. We know, first of all, that a is going to be 6 because a is 6 in this scenario, and it's always the same between those two formulas. So that's really easy. Now we just have to figure out what b is. Again, if we remember that b equals e to the k, then our life's going to be really easy. B equals e to the, well, it tells us in that formula that it's negative 0.04. So now all I really have to do is figure out what e to the negative 0.04 is. So if I go over to Desmos real quick, I say quick, but it needs time to pull up because I forgot to pull it up earlier. All right, so we're going to do e to the negative 0.04. There we go. All right, I'm getting 0.9608. So I'll go back there. All right, so that means b equals 0.9648. All right, so it's a little less than a 4% decay, and that's because it's not continuous versus continuous. So to finish out my formula, I'm going to do 6 times 0.9 forgot my number, 648 to the t power. I'll make that look a little bit better. And that's it. That's all it takes. All right, so now let's talk about the growth or decay rate. So per year, I'm going to base that on the standard formula here. Per year, my growth rate, or actually in this case it's a decay rate, would be 3.52%. And I'll just put a capital D there for decay. 3.52%. Again, I got that by taking 1 minus 0.9648, and that would give me 0.0352, and then just move the decimal, 3.52%. Okay, whereas for the continuous growth rate, that's going to be what it gives us for the K up here. So the continuous growth rate is 4%, and that's also decay. I apologize for my writing. It's on us. I don't have a stylus, so I'm just using my finger. Okay, so there's that. So let's finish out the rest of this table. All right, so the next one, again, we're looking at b equals e to the k. This time they give us the standard format, and they want us to find the continuous format. So we do know that b is 1.2, and we don't know what k is. All right, based on your properties of logs that we learned about last time, you should know that to solve this, we're going to take the natural log of both sides. And so when I natural log both sides, I'm going to get natural log of 1.2 equals whatever k is. So I just need to do the natural log of 1.2. So that's ln 1.2. I get 0.1823. So k equals 0.1823. So I'll write my formula. We're going to have Q equals, A is 5 times, E to the 0.1, nope, not 8, 1823 T. Okay, my per year or annual growth rate is 20%. And that's because my growth factor is 1.2. That represents a 20% growth because it's 0.2 above 1. And then my continuous growth rate is going to be 18.23% growth because my k value is 0.1823. All right, so what would be best here is if you would just pause the video and try the next one completely on your own. All right, so again, going back to b equals e to the k, we know that 0.91 equals e to the k. So I'm going to take the natural log of 0.91, and that should give me k, which is going to be approximately 0.91, negative 0.0943. Negative 0.0943. Okay, that looks all weird. So we'll have Q equals 10e to the negative 0.0943t. This is my formula. I have it's 0.91, so that would be a 9% decay. Okay, and then on this side, it'd be a 9.43, 43% decay for the continuous. All right, there you go. So that's kind of the first step into dealing with these two different types of formulas.